Hi folks, in this video we practice translating numerical claims like at least. So pause your videos now and see if you can translate at least two people are guilty. Okay, that was your chance to pause your videos. My first attempt was to use G as the guilty predicate and to use two quantifiers. So I say someone is guilty with an X and someone is guilty with a Y. But remember, different quantifiers don't necessarily pick out different objects. Variables are interchangeable with each other. They're just another way to say the word it. And so all this really says is someone is guilty and someone is guilty. And if there's only one person who's guilty, that's going to make this thing true. It's just, I'm sort of being repetitive here. So this is not the correct translation so far. Remember, I didn't use P for a people predicate just because I'm assuming my domain is people, and that simplifies the translation a little bit. So what I need is some other thing to show that this first guilty person is different than the second one. What I need is the identity predicate. So this starts to show you how it's very powerful to have the identity predicate in our language. I need to say X and Y are not the same person. Now this looks a lot better, but there's still a problem here. The problem is the scope of the quantifiers. These quantifiers are both narrow scope, and that means this X and this Y out here are free variables. They're not bound by those quantifiers. And I need not just to add some more quantifiers back here. I need this X to be this guilty person who's different from this Y, this guilty person. So what I need to do is I just need to expand the scope of my existential quantifiers. If I have them wide scope stacked out here, then they range over this whole sentence because of the parentheses. This finally says there exists some X and some Y such that X is guilty and Y is guilty, and X and Y are different. And if you think about it, that really does mean that at least two people are guilty. This is not the only way to translate it because, you know, by the quantifier reorder equivalence, you could shift these around, but this is going to be our standard basic translation. There's a general lesson here, which is when we're trying to translate at least n for any number of people or any number of things having some property, you just need that number, n number of existential quantifiers. So I'm going to call this last thing here the Distinctiveness Clause, which says the X and the Y are distinct from each other. Of course, if I'm saying like there are three dogs, I need to make sure all three of them are distinct from each other. So the more and more things you add, you're going to have a huge number of distinct clauses in your distinctness claim out here. But nonetheless, you can get the rough formula. You need to say, if you want to say there are at least three dogs, you need an X, Y, and a Z. You have to say that they're all dogs, and then you just need enough inequalities to make sure they're all different. All right, thanks.